Let's perform a live NAT configuration together on R4. Notice R3 is also connected up to the internet, but we've shut off that interface so that way there all traffic is concentrated over towards R4, where we will perform the network address translation in this particular example. Now, ISP-A is configured to block all traffic that is sourced from RFC 1918 addresses, so all of those private IP addresses which we are using in our topology. As a result, nobody is going to be able to get to the internet until we perform network address translation. So as an example, if we ping 192.0.2.1 from R1 and we source it from its inside interface of gigabit 1/0.1, which has an IP address of 10.1.1.1, we can see that the ping fails, and it's failing because of the filtering that's happening on ISP-A. The packet right now that is being routed out R4 has a source IP address of 10.1.1.1, which is in that RFC private range. So we're going to perform network address translation on R4, so that way that same ping will now be successful because the source address of 10.1.1.1 will be translated to the IP address that is associated with Fast Ethernet 3/0. We'll also make sure that we enable PAT so the other interfaces, the other users with IP addresses can be translated as well in the organization. Let's go ahead and configure our interfaces first. So interface gigabit Ethernet 2/0 is going to be IP-NAT inside. We have interface serial 1/0, which is going to be IP-NAT inside as well. And interface serial 1/2, which is IP-NAT inside. And then interface Fast Ethernet 3/0 is IP-NAT outside. It's our outside interface. We can verify these interfaces by using the command show IP-NAT statistics. We look at the output of show IP-NAT statistics. We can verify the outside interface is indeed Fast Ethernet 3/0. And then our inside interfaces are serial 10, serial 12, and gigabit Ethernet 3/0. Now let's go ahead and identify our interesting traffic. So what is the traffic we are going to be translating? Well, those are those private IP addresses in our organization. So we'll configure an access list, in this case access list 1. We're going to say permit 10.1.1.0.000.255. So any packet with a source IP address within this range is going to be translated. In addition to that, we're going to create another access control list for all of the addresses in the 172.16.32.0 through 172.16.32.255 range. So this will take care of all of those end stations we have off of R5, R6, and R7. Notice that our access control list is not going to be permitting any translations for the 10.1.13.0 or 10.1.23 networks or 10.1.34, the 172.16.33 networks. Those are the networks between our routers. So if we ping from one of those interfaces, translations are not going to occur for those packets. Now that we have our access list defining our interesting traffic, we are going to use the IP-NAT inside source command in order to bind together this access list with the IP address that we want to use for the public connection, so the translated address. So IP-NAT inside source, and we specify lists. So the list is referring to the access control list. In this case, it's access list 1. And then we are going to use the interface of Fast Ethernet 3/0 in this case. But remember, you can use a pool. If we defined a NAT pool, then we could specify the pool in this case. With the pool would have a grouping of public IP addresses. But in this example, we're just going to use interface Fast Ethernet 3/0. And let's not forget about that overload keyword because I want to perform PAT, port address translation, on the packets. So we're going to use the keyword overload. If we look at the output of show IP-NAT statistics now, we can see from this output that down at the bottom, it's telling us we're using inside source, and we have access list 1 defining the private IP addresses in this case, and they're going to be translated to the IP address of interface Fast Ethernet 3/0. And so far, the reference count happens to be 0. So with this set up, we have our interfaces verified. We've set them up correctly, and we have our mapping that's been done. If we go over to R1 and we perform the same ping, we can see that the ping is successful now. Let's go back to R4. We'll look at show IPNAT statistics. We'll see that a total of 10 packets were translated in total in this case. And the reference count is 1. So what's the reference count referring to? It's referring to that particular access list. We've had that one translation so far, or not the access list, but the IPNAT inside source command. We've had one translation in this particular case. So if we look at the output of show IPNAT translations, we can see our translation that has occurred. So the inside local address, that's that private IP address of 10.1.1.1. There's the port number that's being utilized, and there's the inside global address, or the public address in this case, of 203.0.113.2 with a port number of 1024. The outside local was the IP address of the web server that we contacted on the internet, and the outside global is the exact same. Go back to R1. Just going to issue that ping again because we don't want that translation to time out right now on us, because I want to add another translation in the table so we can see how it's slightly different. And in this case, we pinged from 10.1.1.17, which is the IP address of gigabit 1/0.16. Let's go back to R4, and we should be able to see two translations now in the table, and you can see the same inside global IP address being utilized. So it's the IP address of Fast Ethernet 3/0, but now in this case, the port number is different. So the port numbers with port address translation are making sure that we have these unique translations in our table. And reviewing show IPNAT statistics again, we can verify that we've had a total of 30 translated packets, and in this case, based on our IPNAT inside source command, we have that reference count of 2 now for the translations that have occurred. I want to show you what happens though if we ping from a different source, like 10.1.13.1, which is the IP addresses, the IP address of R1's gigabit 2/0 interface. This should fail, and it fails because if you remember from the access control list we created, show access list 1, yeah, it doesn't fall within that range. It doesn't fall with any of those ranges we have specified, so it's automatically denied because of the implicit deny all rule at the end. So the access list is very important. Your IPNAT inside source command, very important because it binds the access list to either the pool or the interface that you're going to use the IP address from for the translations. And it's very important that you get your interfaces correct, because if you accidentally put the inside interface as outside or outside as inside, then the translation is not going to be happening correctly on the router.